Cloud on Air, the journey from big data to AI. My name is Karthik Trasi. I'm a customer engineer in Google Cloud.
And I'm Eric Schmidt. I'm a developer advocate in the Google Cloud Platform team. Thank you for joining us today.
Just as a reminder, we have Googlers on standby. If you have any questions, feel free to post it in the Q&A section below. Today, we're going to talk to you about marketing analytics on the Google Cloud Platform. We know that it is difficult to get a holistic view of all your customers, simply because most companies use over 30 different tools and over 100 different data sets. This is what a typical user journey looks like. If you want to unlock the power of your data, you need a customer data platform, not just tools. Moving your data into the cloud and applying Google's marketing analytics tools will reveal new insights and enable you to make even smarter business decisions faster than ever. So this is what a reference architecture would look like for marketing. We see your data journey moving through 5 distinct steps. Collect, which is bringing all your data onto one common platform. Transform, which is preparing your data for analytics. Analyze, which is running queries over these different data sets. Visualize, which will democratize the data and give access to all the different users in your organization. And activate, which turns insights into actions. So now let's go and see what this looks like in the Google Cloud Platform. So what you're looking at is the user interface for Google BigQuery, which is our enterprise data warehousing service, which is fully managed, no ops. You simply bring in the data, and you write your queries. What we've done is we have built out the data transfer service, which allows you to bring in Google data sets along with your other data sets programmatically, so that you don't have to write code to access the APIs. You can simply add transfer, select the data source, select the destination, fill out the project details, and you will see that your data starts populating automatically in the different tables within the data set. The data will be automatically date partitioned, so it is ready to query. You can use standard SQL to query against the data. And you see that the querying is interactive, so that you can start building your queries at scale interactively. Sometimes you need to transform the data. And here is an example of user session level information from users' shopping cart. So, and I want to do kind of a market basket analysis using this data. And you see that this is quite powerful data, because now you can create like a recommendation engine based on the products that are extremely popular with your users. Now, we realize that traditionally, if you want to use traditional tools to transform this data, you would either have to use Python, Spark, a lot of coding, or even if you want to use SQL, you would use regular expressions, which makes it a little complex. So we want to make it easy for you to transform this data. Hence, we launched the tool called Data Prep, which allows you to play around with the data in an intuitive manner. And the software will come out with suggestions on the ways you can transform this data in a meaningful way. Here I see that the data was in a non-standard key value format. And I have a suggestion here to extract the key values pairs in a nice JSON format. And simply by looking at the histograms on top, you see that it's a much cleaner format to work with. I can start building this recipe, which is basically a step of transformations that I need to take to clean the data so that I can query it easily. I'm still not done with this transformation, because I want the data in separate columns so that I can query this easily. So I simply select this column and select the option to transform by splitting this into 4 different columns. And here you see in the preview, which is in light yellow, that I have now moved this data from a JSON format to 4 different columns. And now it is very easy for me to query. I can add this recipe and review the recipe. And now I still need to run this at scale to terabytes and petabytes worth of data. So I simply click on Run Job, define the location I want the data to be landed, and I want the data to land back into BigQuery. So I have defined the table that I need my data to go into, and I simply click on Run Job. And this will kick off a job which will use the power of distributed computing to parallelize the job and get this done as quickly as possible. So now that I have transformed this data and put it back into BigQuery, I can start analyzing the data. But now, for business users, I would want to visualize this data in a nice way so that I don't have to write SQL queries. So we have a tool called Data Studio on Google Cloud Platform, which is essentially free for unlimited use. And you can start building dashboards, which helps you visualize the data in an intuitive manner. Here you see a dashboard where you have 4 different data sources in BigQuery. You have your CRM data, sales data, Google Analytics 360 data, and DoubleClick data, all in one common platform. So you can join and dissect the data across the various dimensions and metrics. Remember, I showed you how to transform the data. This is what the transformed data looks like. On the right-hand side, you have the data in 4 different columns. Now I can simply aggregate the data to create a product affinity matrix, which can serve as a recommendation engine. Now that I have transformed data in BigQuery, I can do all the cool stuff, which is machine learning. So here you see how I've used machine learning to create customer segments. And now you can see the high-value customers pop out, and now you can focus your campaigns on dealing with the high-value customer segments. So now let me pass it on to Eric, who will talk more about machine learning on BigQuery.
Thanks, Kartik. In this section of the talk, we're going to transition away from looking at, say, classic data analysis on retailing information like what did people buy, potentially what types of products were grouped whenever they made the purchase. We're going to focus on the product view and the customer view. Why did they buy a particular product? And are there things that we could do to help positively influence their purchasing decision, potentially making their purchasing path more efficient? Building on top of the storyboard that Kartik talked about, let's walk through a slightly different user journey. In this case, put yourself in the shoes of someone who is needing to buy some skin cream to help them maybe with an acne problem. And this is something that we as internet users do on a daily basis. We go to our favorite site or sites, we type in a query, or maybe we do some structured search. We look at those results ranked by, say, top rated or price. And then we spend, say, 10, 15 minutes looking at different comments to figure out, is this product right for me? Is this going to help me with my concern? And we'll keep moving through those comments. We'll move through products. And hopefully, from a retailing perspective, you make a purchase. And from a consumer perspective, hopefully I find the right product. This is how things work today. Let's dive into this a little bit more, and let's play a game. So go ahead and read this comment. Read it, not to say as fast as you can, but read it at a normal speed and try to figure out, is this comment a good comment for me, for my concern? Think about, do you trust the user based on the language that they're using? Think about the feelings that you may be having. Do you feel reinforced or positive? Do you feel like this comment is trustworthy? Does the content of the comment match the 4-star rating? Now imagine, and we do this a lot, doing this over and over again for making a purchasing decision. There's a lot of inefficiency and potential frustration that bubbles up in this process. So how could things work better? So I have the same user journey, and I potentially have a different sort order for the results that I typed in or that I made a structured search for. So in this case, I now have a sort order that's a composite of sentiment, user sentiment, and effectiveness for the product. We also are going to attempt to improve this process by reducing the amount of time that a user spends looking at user comments. So we're going to help them look at the right comments to make a purchasing decision. And finally, hopefully they make that purchase and we can ship it on the way and then analyze all types of interesting marketing analytics. Extending the architecture that we showed before, I'm now going to build several data science workbooks, focus on 3 different flows to help build my new ranking, as well as my sort and filter order for user comments. I'm going to use some additional cloud technologies. Specifically, I'm going to use the Cloud Natural Language API to help me gain better insight into my user comments. I'm going to use Cloud Data Lab, which is an optimized version of IPython notebooks, helping me interact with services on the Google Cloud Platform, like BigQuery. And then I'll also dive into some machine learning techniques, leveraging Keras, TensorFlow, and Cloud ML. Let's jump over and see how this looks on the Google Cloud Platform. Now, to begin with, let's look at a real, but in this case, a real fake site. We created this site. It's a fake site called You Look Marvelous, and it's a retailer of cosmetics and beauty aids. So I can do my structured search for moisturizers or eye care, etc. And I'll go ahead and pick one. And the results that come back, the default sort order that come back, is something that we created called the You Look Marvelous score. And it's just a composite ranking of effectiveness and sentiment. So you can see how this is potentially different than, say, a sort order for price or maybe by popularity. Because as a consumer, I may not necessarily concerned so much about price and popularity. I'm concerned about treating my acne problem. So here we're adjusting the sort order to be more focused on effectiveness and sentiment. And whenever I click into a product, in this case I'm clicking into a particular skin cream, you can see the overall ratings for the product. You can see some additional information. I'm also showing you a little bit ahead in the demo. I'm also showing that showing you that we've analyzed the underlying emotion of the sentiment for comments. And I've ultimately driven a new sort and filtering order for the comments that you see here. So now that you understand how You Look Marvelous works, I'm going to show you how we put this all together. We're going to take a journey through 3 notebooks. The first one is understanding the underlying sentiment of comments. This is where I want to build my new sort order and my new filtering mechanisms for comments. In my Cloud Data Lab notebook, one of the first things that I do is I go ahead and I use our magic syntax to go ahead and bind a query that the underlying source is in BigQuery, showing you, as Kartik talked about, the different tables that he enriched inside of our BigQuery data warehouse. So here I write a simple query, and I'm going to pump the results from that query into a Pandas data frame. This is the space where I feel comfortable. I'm inside of Pandas data frames, and I can go ahead and do my traditional kind of data analysis, data science workflow. So this query shows me the overall star ratings for my products. And You Look Marvelous is a successful retailer in that the products that we sell, as you can see, are highly rated. Predominantly all my products are tightly clustered. The mean is 4.18, and I have a very small standard deviation. So basically this tells me that overall, people like, from a ratings perspective, they like the products that I'm selling. But I'd like to get more information to reaffirm or maybe discount this analysis. So the next thing that I did was that I took my comment information and I pushed all of my comments, I have hundreds of thousands of them, through the Cloud Natural Language Processing API. Now, if you're new to the Cloud Natural Language Processing API, here's a quick demo from the product page. So I took one of my fake comments and I hit Analyze, and I get back 4 different pieces of information from the API. One, I get the entities that appear inside of my comments. And keep in mind that my comments has multiple sentences. So I'm going to extract the entities, and from there I can see that I have an entity of skin cream, I have an entity of cream, I have an entity called run, and another entity called Bobby, who happens to be a target or a subject of the sentence. You also get the sentiment information for those entities. In my case, I want to understand the sentiment at a sentence level as well as the document level. So you can see how the sentiment is distributed on a per sentence level, and you can see the polarity between I love this skin cream versus my last sentence, which is I wish I looked younger like Bobby. So with this information, I can go ahead and build a data flow pipeline. So similar to the techniques before that Kartik was showing you, I can build a data flow pipeline, read all of my comment information from my transactional system. In this case, my comment information, my raw comment information is sitting in my transactional spanner database. I can read it in and then drive a parallelized process over hundreds of thousands or millions of comments to then get my sentiment information, my entity information, and other information, say like the syntax tree, back from the Cloud Natural Language API. This is a perfect fit for an embarrassingly parallelized problem set where I have hundreds of thousands of comments. I all want to do the same thing, and I have the same destination, which in this case are 3 tables inside of BigQuery. So after that process runs, and that process took around 45 minutes or so with the resources that I had. And again, since data flow is a fully managed environment, you can increase the resources to decrease your clock time. I now have the information to carry on my analysis. So in this case, I want to go ahead and look at the distribution of sentiment inside of those comments. And at first glance, whenever I looked at this, I felt good. I was like, hey, wow, I have very tight clustering. Overall, people like the products that I'm selling. But then I started thinking, well, if I'm using star ratings as a way to kind of disambiguate one product for another, and they're tightly clustered, it's going to be hard for me to disambiguate one product from another if all of the comments are tightly clustered. So I need more information. Now, before I went on to extracting more information, I did a little bit more analysis just to check myself. So here I'm taking all of my products and I'm basically looking at a star rating on the x-axis and the average sentiment on the y-axis. And again, this reinforces that kind of as product ratings go up in aggregate, the overall sentiment goes up. So this is good from a top-level analysis perspective. But where this gets bad is from a consumer perspective. So let's look at one particular product. This is one product, the same product that I showed you on the YML site. And in this case, the information now becomes a challenge for the user. So you can kind of see between 3, 4, and 5-star ratings, the means are quite close. So it's hard to disambiguate whether or not this is a good product or a bad product if you're looking at 3, 4, and 5-star ratings. So again, I need more information. So I did some research to understand, is it possible to dig into the emotion behind positive and negative sentiment? And there are multiple libraries out there and different techniques to do this. I ended up using an open source library that was written by a fellow Googler. You can find this on GitHub, and it's called Sirocco. And what Sirocco does is it provides you detailed information about the emotion that sits inside of sentiment. So you could think of an emotion like love. Love is a combination of trust and anticipation. So you can imagine from a user's perspective, you'd be reading a comment, and if you see elements of trust and anticipation, you can infer that the commenter loved this product. So I ran my comment corpus through the Sirocco API, and I'm now afforded the opportunity to write a much bigger query, a more complex query. And the result of that query looks like this. That same product now produces a heat map, so I can see the distribution of emotion inside of sentiment by star rating, and I can ask some interesting questions, although I start deviating from my data science goal, which was to come up with a better sort order. But you could ask questions like, why is guilt or sadness showing up in 5-star ratings? And I assure you, as you further analyze the information, you can answer those questions. But in my case, I wanted to build a more meaningful sort order. So I did some more research, and it turns out that one of the things that users are looking for to understand if they're reading the right concepts, the right comments, is the concept of objectivity. And with the research that I did, it turns out that there's an inverse relationship between objectivity and emotions. So using a fairly complex query, in BigQuery, I was able to partition all of my comments by stars as well as by their overall emotion level to start understanding objectivity or lack thereof. So these query results shows us the most emotional comments the top 2 emotional comments per star rating. So you can see, I love, love, love. I can't stop going on how much I love this. Now, this may be an interesting comment, but it has a lot of emotion. It doesn't provide me with an efficient, kind of compact set of information about the product's effectiveness. So with that same query, I basically reverse the logic to go ahead and pull out the emotion in order to get to objectivity. Here's the reverse of that. So now that I've run this query, I have the ability to see highly objective comments like hydrates without a greasy feeling, absorbs into skin quickly, and is lightweight. So with this information, I now have the first knob that I can use to, in essence, drive objectivity into my comment sort, enter, filter ranking. I could also play around with this and say I want to see it, some objective, some emotional, some positive, some negative. Once you have this information, you can end up creating a very, very flexible knob to turn. But this is only one knob. The second knob that I wanted to build was, could I classify the age of a commenter in order to understand whether or not the commenter was a baby boomer or a millennial? Now, in my case, around 20% of my data, commenters have attributed some type of age information into 6 different categories. So 80% of my comment information does not have age information. So my challenge here was, could I write a machine learning, could I build a machine learning model that could help me classify age for comments that did not have age inside of them? For this, I used Keras running on top of TensorFlow to implement my model. And one of the interesting things that I wanted to point out is that I started this notebook by using the same techniques as before, where I defined a query against BigQuery in order to get my information into data frames. And why I like doing this is because once I have this query, the results from this query are in essence guaranteed. You can use them as idempotent. So every time that I run this query in order to do testing on my model, I'm going to get the same input information so that I can more effectively understand the accuracy of my model. Now, once I have my data loaded up and I've split it into split it into training and evaluation, I'm ready to go ahead and start building the individual parts of my model. So here I'm using Keras, and the area that I highlighted highlights that I'm using a convolutional one-dimensional model. And I'm also inputting the overall length of the comment. So I'm using 2 different inputs to drive the overall model. One is the length of the comment, and one is a matrix of the top 100 words, top 300 words inside of a comment, mapped to the most 100 words that are most closely related to them. In essence, I've built an embedding. So with this very large matrix and the length, I go ahead and stitch together several layers with the target of basically 2 buckets. One would be a bucket for millennials, and another bucket would be for boomers. I go ahead and train this model, and with the information that I have, this was just with a couple of trial runs, I can get to around 62% accuracy. So this is much better than a coin flip. Now, in a production environment, I would continue to do this. I would improve some of my data quality issues. And I think if you could get this to 70, 75%, this is another very good indicator that you could use to drive your sort order. So here's an example output that was tested against. So the actual label was 1, which was a millennial. The predicted label was 1, and then here's the content. I'm a teenager, so I have started to break out, et cetera, et cetera. So great, I now have my second knob built. The third knob that I wanted to build was the ability to understand the context or uniqueness of a particular comment. So just because I understand its objectivity and I understand its age range, I want to understand how unique this comment is. So in this case, I used a different technique, natural language processing technique called word2vec. And with this information, I can go ahead and look at how words cluster in terms of their closeness to other words and start targeting outliers. In this example, I ended up looking at a word that shows up a lot, which is love. So you can see love is very closely related to skin, it's very closely related to face, etc. But if I do the inverse, love, if I look at what is the most distant from love, you can see things like disappointing and oh my God. Now, you could continue to go down the rat hole here, but with WordEvec and technologies like this, you can now create a third knob, which is to say, hey, I want to find the comments that have the most unique language inside of them, and then I can swap in and out objectivity as well as age. And with those three techniques, I can come back to this. I can drive a sort and filtering order for my comments that hopefully help the customer have a more efficient and more reassuring purchasing process. And to tie this all together, this site is instrumented with Google Analytics. So what Kartik showed you about ingesting information into BigQuery in order to do that analysis, I can use that exact technique here. I can go ahead and analyze my Google Analytics information to understand the effectiveness of this new sort order. We just showed you a lot of information in a short amount of time. At the end of the day, our goal is to help you to get insights faster, both out of your data as well as the data that you're creating on Google properties. Through the power of the Google Cloud Platform, we want to help you get to the answers to your problems, to truly tough problems, within seconds and minutes versus hours and days.
And what we just showed you is built for analytics. We want you to focus on your results and not your tech. So I hope you enjoyed the show, and we look forward to what you can build. And stay tuned for the following sessions.
So our industry solutions track has just joined us, and they were talking about smarter marketing with Google Cloud.
Yes, and I think just to add on to that, we have the next track coming up for industry solutions is accelerating delivery of healthcare solutions with Google Cloud and AI. Now, Jay, there have been quite a few amazing use cases that I've seen in the healthcare industry all across APAC, be it ANZ or India for that matter. So there have been quite a few use cases, and I think it would be interesting for our audiences to go and watch that session, because that would give them a whole list of use cases and ideas about what Google can do in terms of ML and AI and how we can help the healthcare industry.
Definitely, and actually what I really love about that industry solutions track is it is about how we actually apply AI today into these verticals. So it's extremely, it allows you to sort of understand how you might use those same sorts of solutions in your industry, even if that is not your particular industry.
Interesting. And also, I think with the session that we just ended, what we need to understand is that AI over a period of, if we go ahead and understand it, okay, I think I'll just break there because we are having our big data track audiences just joining us. So the big data audience just finished up with a session of reimagining data warehouse with Google BigQuery, what's new and what's next. So welcome to the audience joining in from big data track.
Great.
And Jay, do you want to introduce the next track that we have for big data?
Sure. So the next track we have for big data is taking a look at data warehousing with BigQuery. So, there's lots of data that's being collected, and we talked previously about complex analytics and moving those to actionable insights. And sometimes those solutions aren't necessarily around machine learning. Sometimes there's easier ways or ways you can use as a managed service in order to get those actionable insights. And moving your data warehousing to a tool like BigQuery allows you to do that. So enjoy the sessions.
We'll see you right here after the tracks. And don't forget to ask as many questions as you have about the sessions. You have the Q&A button right on your left-hand side, the right to Jay. So yes, we'll see you again.
Greetings. Welcome to Cloud on Air, the journey from big data to AI. My name is Evren Eryurek. I'm the technical director in the CTO office of Google Cloud. And today I'll be talking about healthcare solutions that we're building with clouds and AI technologies with many of our key partners. Throughout the event, you can ask your questions, and our experts are online, receiving your questions and responding to you as fast as they can. Please ask away. Every one of the companies that I talk to, regardless of the industry that they're in, are faced with similar challenges. What to do with the data? How can they be much more data-driven? How can they really find the right talent and retain them? How can they be more agile and deliver solutions much faster than they have been doing it? And of course, everybody has security and compliance as top of mind for themselves. When you look at everybody and all the industries, we know data is everywhere. It's coming out every minute, every second, from the applications we use, from the tools that we use, from the devices that we use. The key is, the data that you're sitting on, is it actionable? That's where Google Cloud comes in and helps you accelerate achieving those insights from the data that you're sitting on. Throughout, you're going to be hearing about this in this event. When I look at cloud and what it means for the healthcare industry, it's a massive shift. It's a big way of changing from how we used to do things to what is happening in the new world that we're looking at. We go from CapEx world to an OpEx world. We go from rigid applications to a very flexible, easy to use applications. We go from siloed data to integrated solutions. It's all about the patient, where you can actually achieve a true patient-centric view of the applications. Many ask us, regardless of where we are, why now? Well, it's a very simple answer. Look at the accessibility to the super technologies that we have in our fingertips. Our kids have access to better technologies than all of us did throughout their school years. We're always connected, and we have access to massive data sets. No matter where you are in the world, no matter where you're looking at and what you're trying to solve for. All these three come together and actually achieve what we want to achieve, and this is why now. Before I go too deep into the Google Clouds, I wanted to actually highlight what we mean by Google Clouds. Within Google Cloud, there are a few things that is really important to highlight. We're all familiar with the Google Cloud Platform. It's your infrastructure as a service, it's your platform as a service that we're building all these applications on this massive network that we have. On it, we also have the maps, we also have the ML APIs. We also have what's called G Suite. It's a fantastic application when it comes to healthcare and achieving collaboration between the physicians, between the specialists, among the care delivery institutions. You can actually achieve all that with G Suite, very readily available, HIPAA compliant environments. Chrome and Android, it's designed for healthcare. One of the things that I learned over the past year when I joined, since I joined Google, is how Chrome and the Chromebook and Android applications and the infrastructure is really designed for healthcare. Today, we can achieve all the specialist desks, all the multi-user environments that we can actually deliver solutions. Take a look at the Google Class. The Google Class and its applications for the healthcare industry is going to really enable patient engagements. It's going to enable your transcription. It's going to enable your access to medical records. We've seen some examples already in some key institutions who are leveraging Google Cloud and Google Glass. All these products, 7 of them have over 1 billion users. One of them has 2 billion users. And to achieve the user experience throughout the world, globally, 24/7, we had to build the world's best network, hardware, software, and operations. That's what we have as Google Cloud. A couple of years ago, we've decided to open up this massive capability to all the industries to leverage the technologies that we have in hand so that they can deliver their solutions for their industries. To achieve this, Google built its own network. We run our own fiber optic throughout the world. With this massive network capability, we can achieve the experiences that every one of us are faced with, and experiences that we are all enjoying no matter where we are in the world. Over 30% of the internet data goes over our own network. And to do this, to manage this, we spend over 10 billion every year to really sustain this capability for our own applications, for our own use cases. Imagine what you can do in your industry massively leveraging these capabilities. When it comes to healthcare, two things are common questions: security and compliance. Without these two, and they're always going hand in hand, we cannot really talk about healthcare applications and delivering healthcare applications. In security, we have over 750 dedicated engineers working day in, day out, 24/7, working with the world's best institutions to really establish the highest levels of security requirements. We do this thing by spending over 2 billion alone to achieve this capability. And doing this thing comes rather easily for us, because when you look at Google Cloud and its software and its hardware, from the lowest level of the chip all the way to the servers that we build and we deliver our capabilities, hardware and software are all built by Google. At a given time, we're one of the largest hardware manufacturing institutions in the world. And this is what really gives us the differentiating capability. Our software and hardware at the root of it trust each other, and no other software can get in there. We do not have Patch Tuesday events on Google Cloud that one can actually use to get in and use it as a weak spot. When it comes to compliance, all of these have to be met, especially to deliver healthcare solutions. We've received all the compliance, and we're working even more on these to really expand our compliance capabilities. When you look at 27018, one of the ISO certifications that I want to actually highlight in here, that's designed for data. How you deal with data,